how are you? Wish you are all healthy and safe. Today inshallah we're gonna start a new unit in Model H, Unit 5, lesson number 1. Our lesson for today will be about solutions. So inshallah by the end of this lesson we're gonna be able to define solution, the meaning of solution, and how to distinguish between solution and other types of mixtures. At the same time, inshallah, we're gonna identify the main parts of solution. So let us start with the definition of a solution. A solution is a homogeneous mixture in which two or more substances are so completely blended and evenly distributed that you cannot identify the different parts. So, as I said, solution is a kind of mixture, and when we say mixture, we mean that this mixture is made up of different atoms or different molecules that are not chemically combined with each other. And when we say homogeneous mixture, we mean that the particles of these mixture, the different particles of these mixtures, are evenly distributed through this mixture. So, to understand more what do we mean by solution, let us study the following diagram, guys. So the first image here shows us a kind of solution. As you can see here, this compound represent the water molecule, and the yellow bars represent the solute or the particle that will be dissolved in this water. So guys, again, this is our solution, and as I said, it's a homogeneous mixture. Why homogeneous mixture? Because as you can see here, the particles, the solid particles, are evenly distributed through the solution or through between the water molecules. If we want to study the size of the solid or the solid molecules, the particles here, we can see that they are small comparing with the other type of mixtures. So as you can see, the particles here are small. That's why they will be able to evenly distribute it through the solution, and they will not settle out of the solution. Okay, so this is the main characteristic of a solution, that the particles inside the solution are small enough not to settle or not to be separated by a filter. If we try, for example, let us consider the sugar with dissolved in water as an example of a solution. So after you mix the sugar in a certain amount of water, you will not be able to recognize the sugar particle inside the water. Why? Because here we can say that the particles, the sugar particles, all dissolved in the water or in the solutions, and they just disappeared. Chemically, we don't say that they disappeared, but we say that the particles or the sugar particles evenly distributed within the solution or through the solution. That's why you will not be able to recognize them. Okay, so if we try to separate the sugar particle and to get them out of the solution or out of the water again, can we do that? Actually we can't. If we try to pour out this solution into a beaker or in order to filtrate it, we'll use a filter paper, and you will pour out the solution through the filter paper, but you will not be able to separate the sugar particle out from the solution. Why? As we say, because these particles of the sugar particles are too small, and if we try to allow the solution to rest, would you expect that the sugar particle will settle out of the solution? Actually, no, they will not settle. They will not settle, and they will not precipitate down at the bottom of the cup, for example. Okay, again, why? It's because of the size of the sugar molecule. So the size of the sugar molecules in a solution or any other substance is small. It's very small, which will make it difficult to separate this particle out from the solution, and they will not settle out of the solution. Okay, so that's all for the solution. Now let us compare the solution with the other type of mixtures. We have a mixture called colloid and another mixture called suspension, and we can see here that the main difference between these three types of mixture is the size of the particles inside this mixture. So now here, for example, this mixture is called a colloid, and we can see that the particles here are much bigger than the particles in the solution, but still they have a medium size comparing with the suspension. So the particles in colloid, or the size of the particles in colloid, have a medium size between the solution and the suspension. Okay, so now what do you think? If we allow this mixture to rest, do you expect that these particles are gonna settle out of the solution? What do you think? Actually not. Even though that the particles or the size of these particles are bigger than the particles in solution, but still they are small enough to settle out of the mixture or to be separated. Okay, so now let us move to the third type of mixture. In this case, our mixture is called a suspension, and we can see how much the size of these particles is big. So in suspension, the particles have big size particles dissolved within this water or within the solvent. Okay, so now what do you think, guys? Can you see here, or you can see actually, that the particles here are not evenly distributed through the mixture as we saw in colloid and solution. That's why, guys, here we can expect that the particles here will settle out of this mixture. They will precipitate at the bottom of the container containing this mixture if we allow it to rest. And if we try to separate these particles and to separate them out of the mixture, actually we can do it easily using a filter paper. An example of that, guys, and a common example actually is if you make a mixture by mixing an amount of sand in a cup of water. After a while you try to dissolve it actually by stirring this mixture, but you will not be able to dissolve the sand particles, and then you will start to see that the sand particles will start to settle out of the mixture and to form a layer at the bottom of the cup. Why? Because as we can see here, the particles of the sand are too big. That's why it will settle out of the solution. Okay, so this is the main differences between these three types of mixtures. Again, in solution the particles are small enough not to evenly distributed within the solution, so it will not settle out of the solution, and it will not be separated. For a colloid, the particles have a medium size, but as I said, they are still small enough not to be separated and to settle out of the colloid. For suspensions, in suspension the particles we can see are so big, so they are not evenly distributed through the suspension, so they will settle out of the suspension, and this it's very easy to separate these particles by a filter paper. So there's actually, guys, there's another way to distinguish between these different types. So mixture is by using the light. If we allow the light to pass through the solution, you can see that the light will pass so easily, and it will not be scattered by the particles of the solution. Why? Because the particles are very small. What about colloid, guys? As we said, colloid has medium sized particles, but these particles now will scatter the light that will pass through them. What about that suspension, guys? In suspension, as we said, we have very big particles, and these particles actually will block the light that will pass through this suspension. So the light here will be blocked by the big particles of the suspension, and the light here will be scattered by the medium-sized colloid. Some of the light beams will be able to pass through the colloid, but some of the light beam will be scattered through the medium-sized particles dissolved in this colloid. But for solution, the light will pass through it so easily without being scattered or blocked. So now, as we understood how to distinguish between the three types of mixture, solution, colloid, and suspension, let us move and discuss a little about the two parts of solution, the main parts of solution. Actually, solution is made up of two parts, the solute and the solvent. The solute is the substance that is being dissolved in a solution, and a solid can be a liquid, gas, or solid. What about a solvent? Solvent is the substance in the solution that does the dissolving, and a solvent can also be a liquid, gas, or solid. And guys, as we know, water is the most common liquid solvent. And again, back to the examples we discussed in this slide. For example, if you consider the first solution, which is made up of sugar and water, the sugar will be dissolved within the water. So sugar is the solute, while water is the solvent. And again, for example, for suspension, we discussed a mixture made up of what? Of sand and water. So the sand particles is considered to be solid because it will be dissolved within the water, and the water will be the solvent. So guys, that's all for today. Thank you, and see you tomorrow, inshallah.